And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. And today, as you can see, we're broadcasting from Stygia on the banks of the river Styx. We decided to take a little weekend retreat because the prime material plane of existence has been depressing. We're going to start out today's Daily Space Weather by looking at the colorized magnetogram of the last day to show you 0 sunspots. A couple active regions in the north, a couple active regions in the south, and some coronal mass ejections spotted. We'll get to it. Here's a colorized magnetogram as well as 171 angstroms, and the 2 coronal mass ejections that happened appear to have come from the northwest and the southeast. And there were 2 small solar flares associated with those. They were both B-class flares, not big solar flares. And let's look at some more data before we look at some more stellar imagery. Here's the data from Stereo A, located at Lagrange point 5. And those are sort of in the Earth-facing vicinity, but they are not Earth-directed. So from Lagrange point 5, Earth would be out in this direction. I expect these to miss the Earth to the north and west. So here's a view from the Lasco C2. You can also see Saturn coming out from behind the obscuring disk there, the instrument aperture. And you can see most of the ejecta there can be seen coming out of the west-northwest portion of the corona. Here it is in the C3, a zoomed out image of basically the same thing. And part of the reason we have a channel is to forecast coronal mass ejections and all sorts of other stuff that other people don't seem to be able to forecast. So here's the difference image also, which shows you a little bit additional detail there. And I'll go back to the original image we showed at the beginning to close out this section. And that coronal mass ejection released at about 2000 hours yesterday evening, Universal Time. There could be some additional ejecta associated with this, but so far it looks pretty clear once again. So the radial flux, a 10.7 centimeter radial flux, still at 76, kind of stalled there. For the past, it's been under 80 here for the past about a month. There you can see a little bit of a stall in the solar uptick there. Radial flux 76, and there's the multi-year chart that is available at the Space Weather Enthusiast dashboard. Here's what's going on in the solar system. There's where things will be in a week. And if you're wondering where Stereo A and B are located on this image, they'd be about here and about here. Those are approximately Lagrange point 5 and Lagrange point 4. Next, I brought up a star chart. As I do most days, if you're up before dawn, you may see Venus, the 3rd brightest object in the sky. And if you use in-the-sky.org, there's all kinds of features there. I've drawn in the ecliptic, which is this yellow line. You can see the moon moving into a setting mode there, as well as the celestial pole. Our current celestial pole star, Polaris, is the star around which all other stars rotate. And we've got some fantastic helioviewer movies, as usual. Take a quick look at the fields here. There are the current fields. And again, no sunspots. Here's the fade to 304 angstroms. That's ionized iron, and that's ionized helium. And there's a fade between. And today we've got all full disk images. So here's 171 angstroms for all you stargazers out there. And I would direct your attention especially down to this area. And you can see a bit of activity happening there as that coronal mass ejection gets ejected. And there's a filament up here also. We'll probably make a second video today with some more in-depth images of the sun. Here is 304 angstroms. Still got some pretty major filaments there in the northeast. Oh, it looks like they've collapsed. So we'll save the rest of our HelioViewer movies for the end of the video and blast through a whole bunch more data here from the banks of the River Styx. A slightly more hospitable place than Earth right now. Speaking of inhospitable places, let's take a look at volcanoes. Which volcanoes have been erupting? Well, Karangatang. No, not orangutan. Karangatang has been added back to the list. So Sakurajima in Japan is producing a 7,000-foot ash plume. Karangatang, no, not orangutan. Karangatang. It's an Indonesian volcano. It's producing a 10,000-foot ash plume. Popocatépetl, 18,500-foot ash plume. There, Fuego exploding as well down in Guatemala. Flight level 150. Sangay exploding, flight level 200, and Sabancaya exploding 240 is the flight level above Sabancaya. Please do not attempt to hang glide or pole vault the caldera. Not orangutan, Karangatang. And let's look at earthquakes. Still seeing a 7, 8, and 9 magnitude earthquake drought continuing here. Looks like nothing over a 6 magnitude. There's a 5.6 in Panama. That's one of the largest of the past 24. So a couple mid-5 magnitude quakes. Actually, 2 in Panama there. Perhaps an aftershock. And we'll just scroll up the list here. Let me get that Panamanian quake off. Here's one northwest of Australia at a 5.6 magnitude. Deep quake in the Mariana Islands area, south of Japan. A deep quake strikes western South America in Peru. It's a 4.8 magnitude at 115 kilometers depth. Here's a 5.3 west of the Aleutian Islands and east of the Kamchatka Peninsula. Here's a deep quake in Indonesia. And that's all she wrote for that list. Let's continue on to look at the real-time solar wind. So here's the real-time solar wind, and the most current data is solar wind density just under 5 protons per cubic centimeter, approximately 5 protons per cubic centimeter. Solar wind speed quite low here, and quite low levels of solar activity overall. Once again, you don't need sunspots, to vanish, or solar flares for coronal mass ejections to happen, and it's part of the reason why we started making our daily space weather videos at the time of a solar minimum. And the KP index has been either at 0 or 1 for the past 24 hours. So let's take a look at cosmic rays. First, the Apatity Neutron Monitor. There's a 30-day chart for Apatity. Downtrend on the past 30 days. Flat over the past 2 weeks. Barentsburg. Downtrend over the past 30 days, tiny uptick over the past 2 weeks. Let's go farther south to Athens, Greece. Here's the Athens neutron monitor. And you can see it's pretty flat over the past 30 days as well. Next, going even farther south, we'll go to Mexico City. Look at the cosmic ray monitor there. And like Apatity and Barentsburg, it is actually flat over the past 30 days and a slight uptick over the past 2 weeks. And next we'll look at Oulu and then go really far south to 2 Antarctican monitors. There's Oulu, which is in Finland. Similar to Apatity, Barentsburg, and Mexico City there. Mostly flat over the past 30 and a small uptick over the past 2 weeks. Here's DOMC Antarctica. Pretty flat over the past 30 days there. A small uptick, actually. And there's DOMB Antarctica, which shows a much different range than DOMC Antarctica. And actually an uptick over the past 30 days at DOMB. And if you want to monitor these yourself, just do a search for links to cosmic ray data. You'll find this site. And we show the same cosmic ray monitors regularly on the channel to give people context for what they're looking at. Next, it's time to take a sip of coffee and look at 4 hours of data from the Geospace Magnetosphere movie. We're looking at magnetohydrodynamic pressure here, measured in nanopascals. Actually simulated in nanopascals because this is a model courtesy University of Michigan. It's based on the space weather modeling framework, and going a little closer to home, here are ground magnetic perturbations. Geospace delta B means changes in the Earth's B field, the B field being the field that goes through the magnet. And since we're living through a polar excursion, a geomagnetic excursion you could say, the South Pole has left the Antarctic continent entirely and is in the Indian Ocean. And we've got a North Pole over both northern Canada and northern Siberia, putting the net pole in between Greenland and Svalbard. Now, I want to cover cosmology briefly. Just a little tidbit here about something that came up yesterday. Now, we regularly throw dice to pick a number between 1 and 1031. Yesterday, came up with a star called FK Comey. So, interesting thing about FK Comey Berenices. This is a variable star, and it's a rotationally variable star. Why is that so interesting? Well, it's so interesting because there are some indications that when the sun's activity changes drastically, that the sun's rotation changes. Now, this particular star seems to rotate at different speeds at different latitudes. Now, mainstream astronomy believes that this is because it is a recent binary merger and has not yet reached a state of sort of static equilibrium. But in any case, we see variable magnetic fields. So what we're seeing essentially are stellar holes, similar to coronal holes on the sun. And we're seeing areas where there are large magnetic field differences happening. So perhaps these are stellar coronal holes, and perhaps coronal holes are a clue as to the sun's behavior. So, rotationally variable stars are super interesting for this reason, because again, there is some indication that the sun may change its rotation rate. And so keeping track of the sun's Carrington rotations is very important when you're monitoring solar activity at the level of detail that we do. If you want to read about that, it's FK Comey Berenices. There's a Wikipedia article about it, and I think you'll find some other articles about it as well. Rotationally variable stars are quite interesting. So enough of that. That's today's cosmology segment. Let's continue on. By the way, thanks to our viewers over at Twitch. It's twitch.tv/smAsho. We don't always stream live to Twitch, but it's a great streaming platform. And so that's where I'm currently streaming. Thanks to our followers over there at Twitch. Please tell your friends, foes, science noobs, and science pros. Also, I would invite all of our viewers to visit our own website, smAshomash.com, smAshomash.org. You can find our social media links there, as well as if you scroll down, you'll see links to our stores. Check out our latest store, which is the link for smAsho merch. You can also find our forum there. It's all free so far, and we invite you to post whatever you want. We won't censor you. Perhaps we'll make it into the next social media network, as I need a new job. Also, don't forget to check out the smAsho store and the Smash store, different merch on all of those sites. And perhaps you'd like to pick up a Google Bias sweatshirt or a Fauci fraud sweatshirt, or perhaps a Dimension of the Year, hell, art print. Thanks to our subscribers over at YouTube. Please don't forget to press like and subscribe. Press that notification bell so you know when we put up a video. And don't forget to press share. Tell your friends, foes, science noobs, and science pros. Share on your social media. And thanks for leaving comments, Precious Slights and Kathy Garden. Good morning to both of you. Cheers. And again, the video cannot continue until you press like and subscribe. For those of you who already have, you know, you can pause the video. That's part of the reason why YouTube is good, because it's video on demand, folks. If you pause the video, we'll be here when you come back. Also, thanks to our BitChute subscribers, there is exclusive content over there as well. You may want to check it out because, well, it's exclusive content, meaning it isn't on YouTube and it isn't on Twitch. Next, thanks to our patrons, the true source of funding for the content, the main source of funding for the content. Please consider funding us, as we need lots more income in order to go full-time with the channel. It's patreon.com/smAshomash. Thanks again to our patrons. They're listed in order of lifetime contribution. Next, looking at just a diagram of the atmosphere showing electromagnetic radiation penetration from the sun to your earthly station. And you can see there it's showing visible light and infrared radiation makes it all the way to the troposphere, while things like X-rays are mostly filtered out by the time they reach the mesosphere. Also, if you look at the right side here, you can see the F ionosphere layer. That F, that red F under my pointer, that's the F ionosphere layer where the GOES 16 makes its measurements. So here's the GOES 16 X-ray flux, and you can see these two flares that happened yesterday, and the peak flux here happened at about 2020. 2020. I remember that year. It was the year of accountability. And welcome everybody to the year. 2020 was the year of clarity, coincidentally. And welcome everybody to the year of accountability, 2021. Are you accountable? Next, looking at the GOES proton flux to see no proton strikes. Again, those coronal mass ejections are expected to miss the Earth. We'll be keeping an eye on it for the rest of the day to see if any more happen, and probably making a second video. Another smAshomash.org presents the sun, and if you haven't checked out our playlists on YouTube, head to youtube.com/smAshomash/playlists, and you'll find a bunch of playlists there, perhaps with material that you weren't even expecting. Here's 3 days of GOES magnetometer data. We're seeing pretty high readings here. The south solar polar field looking pretty strong, and the Earth is solidly in a south pole current sheet. And some changes have happened since yesterday. Let's check it out. Here's the top view ecliptic plane field plot, as if you're looking down on the north pole of the sun. And this is showing you the current sheet in its polarity. So it's showing red polarity. It's showing south pole polarity in red, north pole polarity in green. And you can see some activity there out by stereo A. Looking a little indecisive, perhaps there is an active region south of the solar equator. That would be my guess based on that data. We won't worry about it too much. We don't want the video to be too long. It's the daily space weather. Tomorrow I would expect us to remain in the South Pole current sheet, and you can see the Earth's potential field surface source line there in orange, in the red. So here is the B field. We're looking at a line of sight coronal hole plot here. And you can see that South Pole-oriented coronal hole in red just moving past the Earth-facing zone. We can expect a coronal hole wind stream from that in about 2 days. And here's another image, which also includes the solar magnetogram and the poloidal fields. Again, no sunspots. And last but not least, here's the magnetic field diagram of the Sun's atmosphere, otherwise known as the corona. And you can see some coronal hole potential field surface source lines kind of oriented directly toward you, the observer there, right kind of in the middle of the solar disk there. You can see those are coronal hole potential field surface source lines. Poloidal field potential field surface source lines are shown in black, and closed potential field surface source lines are shown in pink. Next, looking at the ionosphere. And the ionosphere is looking pretty anomalous here. Highly discharged on the sun-facing side, at least at the beginning of the video. And we'll bring up the latest image here. By the way, if you know anybody who's able to forecast earthquakes by looking at these ionosphere maps, send them our way, because I'm not seeing it. And frankly, if you can't explain the physics and I can't see the observations, I don't believe you. No, I don't think Suspicious Observers is forecasting earthquakes. I think they have thousands of people trying to win prizes forecasting earthquakes every place around the Ring of Fire, in likely zones for earthquake spots. That's my stance. Change my mind. Here's the electron content forecast. Let me just check the life of the stream here to make sure everything is good. And yes, beautiful day in Stygia. Oh man, the studio's caught on fire again. Now I don't know what's going on with this River Styx thing back here. It's filming on location is always an issue, folks. And the River Styx is just weird. Technically, this is not hell. Stygia is just sort of where the River Styx is located. And yeah, that's all I'll say about that. And we're seeing a forecast here for a dip in the electron flux. I would tend to agree with that. And the electron flux can cause satellite charging, and we do see a little bit of minor charging here, internal charging in the southern hemisphere just south of the equator, especially around noontime. Here's a 3-day chart of the electron flux, and we are still in electron warning levels. And yesterday's peak was at about 3,800 pulse flux units. There's the graph from that. That happened at about close to noontime for the satellite. And if you're a new viewer, you may not know that these N's and M's mean noon and midnight time, local time for the GO-16 satellite. Here's just a visualization of the altitudes of the Van Allen belt, the International Space Station, the Van Allen probes, etc. And your GPS satellites are at about 12,500 miles of altitude. And here's a visualization of the total electron content. This is essentially the inner Van Allen belt, the area in between your GPS satellite and your handset. We do see some anomalies here around Antarctica once again. We'll let it play through. Some anomalies over North America as well there. And those have been regular enough to not be that anomalous anymore. Mainly the Antarctican area. We'll see some nighttime, some midnight GPS errors, actually. Please leave us a comment if you're viewing the video from Antarctica. Here's the 1-year chart of the electron flux courtesy Solon.info, just to put that in context. And I would tend to agree that we'll see a dip in the electron flux here. Next, jet streams. Getting into meteorological stuff. And there's a pretty significant snowstorm headed to the northeast. We'll do a slight video about it. We'll probably make a very in-depth video about it. And this is from nullschool.net. We're looking at the 250 hectopascal winds. of the eastern portion of the planet. Some extreme anomalous jet stream flow down here in the southern hemisphere off the west coast of Australia. Next, we'll rotate this thing around and look at the western world's jet streams, I think. There we go. Let that animate. An extreme meridional jet stream flow here over the western world. Check it out. We've got tripled up jet streams in this area. Extremely anomalous jet stream flows in that area. The jet stream is, to use a meteorological term, a bit jacked up. All right, let's move on here. The GOES lightning mapper is showing us some significant lightning here, especially in northern Texas. And it's about to move across Oklahoma, Kansas, Missouri, eventually into Arkansas, Illinois. Here's a real-time lightning map. It's lightningmaps.org. And let's see where the lightning's striking now while we stream live. Hey, Tulsa, there's thunder rolling in. Maybe not. If you're in Tulsa, go out and look to your west. You may see some interesting features happening. Hey, Oklahoma City, there's thunder rolling in. Anyway, there's your global real-time lightning map. Here's a U.S. Doppler radar map. Snow showers across 2/3 of the country and some heavy rains in the south central portion. Now, here's the Euro forecast for snow. Where I'm located is right about there in the Lehigh Valley, and we're getting a forecast now for 8.8 inches, according to the Euro forecast. That's through Tuesday morning at 6 o'clock Eastern Time. So there's your snow forecast for that nor'easter. That's the Euro forecast. Now we'll also show you the GFS forecast. And they are in agreement. So this is a very similar forecast here. The GFS forecast is forecasting like a little bit more snow, but it's pretty close here. And the heaviest snowfall areas are expected to be in south central Pennsylvania. (17 and 18 inches forecasted for some of those areas. A pretty big snowstorm about to strike a large portion of the northeast. Here is the water vapor map for the Americas. You can see some of the effects of those extreme jet stream patterns there on eastern South America, right around the South Atlantic anomaly, perhaps not so coincidentally. And I just wanted to go back to nullschool.net here real quick, because nullschool.net will show you particulates. You can also see it on windy.com. I just wanted to see if there's Saharan dust. And it looks like indeed there is some Saharan dust. Although it's not blowing across the Atlantic right now. Nullschool.net. It's super useful. You can download windy.com's app as well. Oh, what did I do? What happened? All right, let's continue on here to look at the cloud layer. You can see that strong rotating low there off the coast of the U.S. there, northeast of Bermuda, which is located right here. And here's a water vapor map, and you can see that atmospheric river making its way to the east. Just about to head into Illinois and Indiana, Michigan, etc. Cloud layer, water vapor. And we've got bonus features, but please don't forget to press like and subscribe. Tell your friends, foes, science noobs, and science pros about the channel. We've got lots of stuff to do, and we need your assistance to do so, as we are tanking over here. And yes, Kathy, my snow shovel is indeed prepared. And so is my lower back. So thanks, Smash Team, for tuning in. We've got bonus features, so don't go anywhere. We're going to show you the solar intensity gram and the colorized magnetogram to show you 0 sunspots. We're going to show you the rest of our Helio Viewer movies. So there's the magnetogram. Again, I don't think there's any sunspots. Here's the intensity gram to make sure. And I don't see any ombre in the most magnetically organized regions. 0 sunspots. And we'll show you a couple more images here of the local yellow dwarf. We left off at 304 angstroms. Here's 193 angstroms, which should show you a good view of the coronal mass ejections. Check out the southeast and northwest limbs. Here's 94 angstroms. And we're not playing. There we go. Sorry about that. Please play. Great view of that solar flare there. That came out of former sunspot 2800 in the northwest. You can see that area brightening up 2 times. So both of the solar flares came out of there, but only one of the coronal mass ejections came out of there. The other one came out of the southeast, where there is no former sunspot. There's no plage. There's no real area of magnetic organization. Here's 335 angstroms. I like the cool blue tones of the 335. Here's me vanishing. And have you been noticing this smiley face looking thing going on here? There's a bit of a smiley face feature happening over the past few days. And we'll close things out with 211 angstroms. We don't always show it. It's great at showing coronal holes. And you can see a pretty holy corona here in this wavelength. By the way, this is another one of the wavelengths of ionized iron. And it's about that time. Thanks again for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. No matter how much the government drives you to drink, don't drink it. If you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. Visit our links, and may that solar wind be at your back.